In this video, we're going to focus on another feature enhancement that's been added to the MSO 4, 5, and 6 series oscilloscopes from Tektronix, and that is the ability to perform RF versus time triggering on a waveform generated in Spectrum View. So the setup that I have is this. I have my MSO 64, which is our up to 8 GHz bandwidth, 25 gigasample per second, 4-channel oscilloscope. And I have a whip antenna that's attached and terminated at a 50 ohm termination on the scope onto channel 4. I'm going to use that whip antenna to capture the RF emission coming from a car key fob. Alright, so let's take a look at what this waveform looks like. I'm going to set my scope to acquire a single acquisition, and I'll press my key fob button near the whip antenna. And now we can see in the bottom display the time domain waveform view of the pulse and the frequency representation of this particular waveform. This is showing that the center frequency of this pulse is right around 434 MHz. Now, within the Spectrum View badge, I can also add a magnitude versus time and a frequency deviation versus time waveform. Now let's go back and acquire a new set of data after we've reduced the span in Spectrum View down to 200 kHz. Now we can see that there are two frequency peaks in the Spectrum View. And if we go to our frequency deviation versus time plot and reduce the vertical scale, and then zoom in, now we can see that there's a binary frequency shift keying, or FSK, modulation scheme being applied to this particular key fob. In addition to being able to view the RF versus time waveforms, you can also apply the measurement engine to them. For example, if we want to measure the total pulse duration, we might go into the measurement engine, select magnitude versus time, and select positive pulse width. Now we can see that the pulse width of this particular emission is roughly 31.5 milliseconds. Similarly, if we want to find the frequency deviation peak to peak, we could go into channel 4, select frequency versus time, peak to peak measurement, and then apply a localized time gating measurement to show that the peak-to-peak frequency deviation between these two cursors is 91.28 kHz. Now, using a simple edge trigger like the one we currently have applied for a low amplitude RF pulse can sometimes be cumbersome. If the trigger level is set to be too low, you may end up triggering into the ambient noise captured within the environment. If the trigger level is set to be too high, however, you may end up missing the RF pulse entirely. With the latest firmware release for the MSO 4, 5, and 6 series, we've introduced the ability to trigger on the RF versus time waveforms. So for example, if I go in and select magnitude versus time for the trigger source and acquire another single acquisition, now you can see that we're triggering in on the first edge of the magnitude versus time waveform. We can also apply our trigger to the frequency versus time waveform. So if I change the source and apply a trigger level at 20 kHz and a squelch level of 1 millivolt to avoid triggering on some of the low amplitude, high frequency noise that occurs before and after the pulse, and go back and take a single acquisition, now we can see that the scope is triggering on and capturing the first place in which the frequency deviation waveform is changing by at least 20 kHz. So this is just one application area where the new RF versus time triggering capability of our scopes with Spectrum View will be useful.